All right, well, thank you very much, and thank you everyone for joining us today. I am going to talk a little bit about, there's three things that I want to highlight in my portion of the talk. So I would obviously be in the camp of electrical measurements are not just shock value, they are legit. I'm going to highlight some of the proven history about how electrical measurements, and what we've heard a lot about today is resistivity, about those have a proven history over the last century. I'm going to talk a little bit about how there are a tiered solution, so there's a lot of different options that an agency could implement. And I'm going to talk about why now is a good time, if you represent a transportation agency or if you work with one, about talking about them about how they could use electrical characterization techniques. So electrical measurements in the application of assessing concrete microstructure began about 100 years ago. This technique originally came out of Japan, was traditionally used for setting time. So the concrete sample was pretty far down there in the bottom, and this is obviously before there were kind of accepted methods to assess voltage and current. But essentially they were using electrical resistivity to assess setting time. All the way into the 1980s, when we see the advent of the RCPT, or what is now ASTM C1202, that essentially measures resistivity as a function of time. It integrates the current that flows, and it's really picking up supposed to be picking up on the microstructure of that concrete. Fast forward into the 90s, where we start seeing winter probes applied to concrete, and then in the 2000s, where we see a uniaxial or direct resistivity. Since that time, there's been about 22 state agencies by our count that have implemented quality control or microstructural characterization using electrical techniques. And then in 2024, we've done another interlaboratory study that again highlights that the test method is pretty repeatable, single operator coefficient of variation of about 3 to 6% and multi-operator variation around 20%. 12%, so even lower. And then into the 2020s and into now, where we've done a lot of work on expanding the techniques to measure pore solution resistivity. So we have a project that we're hopefully going to be continuing in the next few weeks. So given that history, and like I mentioned, there's about 22 state agencies that have implemented electrical measurements. Some of the things that we've highlighted is that there are a range of techniques that you could use. You could use ASTM C1202 that monitors the current flow over a 6-hour period. There's migration techniques, and then the popular one that we've talked about a lot today is electrical resistivity. All of these are picking up on the same common traits, but in really which one you implement at your agency is a balance between economics, the versatility that you might need, and the usefulness of the data that you want to come out of it. But all of them are picking up on things that we know correlate to good quality concrete. How consistent the material is, materials or mixtures that have low paste contents, low water cement ratios, and high SCM replacements. Things that we know lead to good quality concrete in our transportation infrastructure. The other thing I like to highlight is that there's a range of complexities, but for the most part, the simple tests serve as building blocks for the more complex tests. So if you start out implementing the easy tests, that's okay, and you have time to build into the complex tests if you want. And so why is now a good time to implement electrical characterization techniques? One of those is our changing landscape of material availability. Whether it's low carbon goals, or whether it's supply chain or manufacturing availability, the materials that we're using in our concretes today are changing. With those come changing qualities and the ways that you combine them to make concrete mixtures. We work with the state DOT that has pretty consistently used water cement ratio specifications for both mixture qualification and quality control. And they have recognized through some of their, I guess I'll say pilot projects of alternative materials that might not be the way to go in the future. So moving towards a more performance-based acceptance and evaluation parameter is a good idea for them, they say. The second component is that It's a durability and consistency assessment that picks up on the things that you're worried about from a quality control point of view. Water content, paste content, whether you actually put cement in or whether you actually put fly ash in or whatever your mixture proportions are. It's relatively rapid. One of the things that I'm not sure that anybody's highlighted is that in addition to a 6-year-old being able to do it, it can be done in a matter of minutes, which is nice. And then lastly, there's a grant program that can help agencies transition this technology and use it in their program. And it's a lot of times right now it's being described as a low carbon program, but it's really being developed to help ensure that the materials are appropriate for use, which is a good application. So, thank you very much. Look forward to questions.